Hi guys, in this video I'm going to go through the Additional Mathematics SPM trial paper for year 2021 for MRSM paper 1. My name is Terry, I'm an Math Specialist. Hope you'll be able to learn a lot from this video presentation. Okay, let's go straight to the first question, right? So here we have a question from Form 4, Chapter 4, Surds, Indices, Surds, and Logarithm. So we are supposed to simplify this equation, this expression here in this form. Okay, the first thing we should do in this case is to perhaps find the square root of 4. We know 4, if I square it, I will get 2. But I still have a there, so we can leave it in the form of root a. As for 3 over root a, we have to rationalize the denominator. Remember, if you have denominator involving surd, we can rationalize them by multiplying top and bottom with square root a. Now, the next thing is I have square root of 9. We can square root 9, leave it as 3, whereas root 9, I will leave it in this form. Now, the next thing is we can multiply this together. 4 times 2, I get 8. Root a, and square root a times square root a is going to give us a. So this is 3 root a over a plus 3 root a. Now 8 root a plus 3 root a, or 3 surd a, right? It will give us 11 surd a, all right? And then you have a minus 3 surd a root a over a. All right, the thing is we have to give our answer in this form. So we have to combine them as a single fraction. So now notice that there is a square root a that we've taken out. So maybe we can factorize the square root a first, easier to see. This is 11 minus 3 over a. And also notice that they combine this as a single fraction. So let me continue here. So I'm just going to multiply the 11 top and bottom with a. So it's 11a minus 3 over a. Just put them together as in leave the root a at the back, so you get 11a minus 3 over a. You can put this in the form of bracket and keep the square root a at the back. So in this case, your b is 1. Now they didn't ask you to state the value of b, so you can just leave it like this. Okay, let's move on to question number 2. So the first part is solving this initial equation. So for me, I would break this up first because this is 5 power x plus 1. We can break it up to 5 power x times 5 power 1. Remember, a power m plus n is a power m times a power n, right? So in this case, when you break it up, it's 5 power x times 5 power 1, and this is 5 power x times 5 power 3. Now, I still have a 5 power x here, just keep it. And notice I have another 5 power x on the right-hand side. Just leave it first. And you have 42x plus 5. Now, we have to factorize this 5 power x. Take it out, 5 power x. This is 5 power 1. This is 5 power 3. And when I take out 5 power x from here, I'm left with just 1. Yeah, remember, if you can't see, you can actually use substitution, because we can just say that this is u, this is u times 5, and the other one will be u times 5 power 3, and the last one is just u. So when you take out u from here, you're left with 5, you're left with 5 power 3, and when you factorize the u, take it out if you like, you're left with 1. Okay, so now the next thing is, let me copy this first, 5 power x, 42x plus 5. Now, the next thing is we can actually cancel this out. Now, I know you'll be thinking, can I actually cross out 5 power x like this? Well, if you have, for example, let's say you have x squared equals to 4x. Can we cross this out like this? No, because we can actually bring it over, right? You can actually bring the x over, 4x over, and when you factorize x, you're left with x minus 4. Yes, x can be 0 and x can be 4. However, in the event that x is a non-zero value, then we can cross it out, right? You see, if I cancel them, x is 4. Now, this is true if x is not 0. Now, can my 5 power x be 0? No. Yeah. I hope you know this already. Any number to the power x, with exception of 0, is always more than 0 for all values of x. Yeah, for all values of x. So it's not going to be, it's never going to be 0. Yeah, you can draw the graph of exponential function. This is exponential function. It's always more than 0. Okay, so because of that, we can now cancel the 5 power x. And that will leave us with this equation over here. This is 5 plus 125 plus 1. Can't work out mentally. Just use a calculator. 5 plus 5 power 3 is 125. When you plus with 1, this will give us 131. So I'm going to write 131 here. And now you're left with 42x plus 5. Yeah, it becomes an easier equation. So bring the 5 over. 131 minus 5 is 126. So I write 42x equals to 126. X is 126 divided 42 is just 3, 12 divided. Yeah, if you, again, if you're not sure, just use your calculator, right? You should get x equals to 3. All right, so the first part is indices, solving initial equation. Okay, second part is logarithm. We're supposed to evaluate this logarithmic expression. So number one, you can see that they have the same base, but they have different number here. So in the laws of logarithm, we know that if I give you log base ax plus log base ay, we can combine it into log base ax times y. So that's what I'm going to do here. I'm going to combine it straight away to square root m n times m over square root n. Put them together. So the more you combine it, you write this as a single logarithm. Now, the next thing is, because of the square root, right, we have to, perhaps I would write this as m power half and n power half, easier to see, right? This is m power, m over n power half. Now, notice that the n and n, we can actually cancel them. Yeah, I can actually cancel this. And I'm left with m power 1 and n power half. And also remember, a power m times a power n, you can add them up, m plus n. So in this case, you will get log base m, m power 3 over 2. Now, we know log a is 1. And if I give you log a power n, the result is just n. Because you can say, you can read this way, a to the power of n is an. So in this case, your answer is just 3 over 2. Now, you don't believe me, you can use your calculator. Okay, log base, whatever number you want. Maybe you can put a 2. And then I put a 2, I power 3 over 2. It is just 3 over 2. Yeah, any values of a. In this case, m also can. You can cancel them. Answer is 3 over 2. All right. Okay, let's move on to the third question. Question number 3. This is Form 4, Chapter 5, Progression. Okay, here we have the first 3 art statues in a cuboid shape with a square base arranged by Ali in his new closet. So the height of the closet is 60 cm. The height of each cuboid is 5 cm more than the previous cuboid. So we have the first cuboid with the height of y, second one y plus 5, third one y plus 10. And they say that the volume of the sixth cuboid is 4005, and the sum of volume of first 4 cuboid is there 11,000. So find the value x and y. Okay, so first of all, we can see that the volume of cuboid actually form an arithmetic progression as stated here. So what we can do is we list out what is the volume of your first one. Now, volume is length, breadth, height. So x, since the question say it is a square base, right? It has a square base. So square base here. So we know we can use x times x, which is x squared. Your height is y, so answer x squared y. Now, your second one will be x squared. However, your height is now y plus 5. So when you expand this, you should get x squared y plus 5x squared. Yeah, just expand one by one. And with that, I can know I can find out my common difference. Basically, my common difference is T2 minus T1. I think you can mentally cross out x squared, y, and x squared, y. You're left with 5x squared. Okay, I've got all my information that I need. I know my A, I know my D. So I need to form two equations. My first equation is this. The volume of the 6 cuboid. So we know T6 is now 4,500. Okay, so I'm going to use A. Remember, the formula for Tn, let me write over here, is A plus n minus 1D. So my A is x squared y. My n is 6. 6 minus 1 is 5. My D is 5x squared. The result is 4,500. Now let's simplify this further. This is x squared y plus 25x squared equals to 4,500. Now I'm not sure what to do with it, so I'm going to leave it out. Now let's look at the second information. You're given that the sum of volume of the first 4 cuboid, they are 11,000, is 11,000. So sum of volume means S4 here, 11,000. And remember, Sn formula for arithmetic progression is 2a plus n minus 1b. So I'm going to write here 4 over 2. 2a, my a is now x squared y, n minus 1 is 3. My common difference is 5x squared. The result is 11,000. So let's just take the 2 and multiply inside. Or you can just multiply over. I think it's easier to just multiply this over instead. So we write 2x squared y plus 15x squared equals 5,500. This is your equation number 2. Now, to solve for x and y, now here's the thing. When we look at this, it looks like a complex nonlinear equation. However, because you have x squared y and 2x squared y, I think we can just eliminate the x squared y by first taking equation 1 times equation 2. When you multiply equation 1, equation 2, x squared y times 2 is 2x squared y. 25x squared times 2 is 50x squared. 4,500 times 2 is 9,000. So this will be your equation number 3. Okay, so now the next thing is we need to solve them by taking equation 2 minus equation 3. Or should I say 3 minus 2 is easier, so I can avoid having to deal with negative number. 50 minus 15 is 35, right? And 9,000 minus 5,500 is 3,500. So my x squared is now 100 here. Square root of 100, x is just 10. Okay, now that I know x equals to 10, now the next thing is, and you find my y. So let us sub inside equation number 1. You can sub inside any equation. So I put equation 1 here. Now in my equation 1, my x is now 10. You square it, this y here. And then you plus with 25. Your x is now 10. You square it. It's going to be 100. Actually, you can just write 100. The result is 4,500. Yeah, I'm substituting inside equation 1 over here. So this is 100y plus 2,500. You add 20 at the back. This is 4,500. So 100y is now 4,500 minus 2,500. That is 2,000, right? And I get my y. Y is 2,000 divided by 100. Cancel the 2 zeros. My y is just 20. All right. Okay, so that is the first part. Okay, I'm going to continue the second part, maybe over here. Hopefully I have enough space. All right. Ali wants to arrange the 10 cuboid horizontally in a row in the closet. Can he do that? Yeah, verify answer by calculation. Now you can see from here. So this is the first one. This is first cuboid, second cuboid, third cuboid. Now, here's the thing. If you keep adding, the subsequent cuboid will be taller than the preceding one. Yeah, it increased by 5. So we are not sure whether he will be able to, the height of the 10 cuboid, the 10th one, will it exceed 60 cm? If it exceeded 60 cm, it cannot fit inside, right? Okay, because we cannot compare the horizontal length because the horizontal length is not given. So the value of x doesn't matter. We do not know how long is the x, but we do know the maximum is 60. You can't exceed 60 cm. Okay, now that I know the first height, right? The first height, y, is now 20. So 20 is the first one. And my common difference is 5x squared, right? Or you can, sorry, my common difference is 5, sorry. This is volume. My common difference from here, you can see, is just 5, increased by 5. So my A is 20, my D is now 5. We just need to find out whether the volume or the height of the 10 cuboid, whether it exceeds 60 or not. So let's find A plus n minus 1. D, this is 45. 45 plus 20 is 65, right? So this 65 is already more than the height. The maximum height I have is 60, right? So this is greater than 60. Okay, how do you explain your answer? Maybe I'll just write like this. Can he do that? Answer is no. The height of the 10 cuboid is greater than 60 cm, right? Or the height exceeds 60 cm. So no, we can't arrange them in a row. Okay, let's move on to the next one. The next question is using quadratic inequality. The diagram shows parallelogram ABCD such that the length of AB is 10 units more than the length of AQ. Now we know area of parallelogram is just length of your base, let's say B, multiply your height, right? So they say the area does not exceed P. So your area does not exceed, mean it can be P, less equals to P. You're supposed to find the range of values of AQ. So your AQ is high. Maybe in this case, we can let AQ be X. Yeah, AQ be X. So your height in this case is already given. Yeah. The length of AB is 10 units more than X. So we say X plus 10, right? Or you can write X plus 10 here. So we know that length of the base, X plus 10, multiplied by your height, X, height of the parallelogram, must less equals to B. So let's expand X squared plus 10X minus P less equals 0. Now here I have two different ways of doing. I think most students will do the standard way. They will complete it, they will use quadratic formula, right? So because we can't factorize this, the reason why we can't factorize is because you have unknown in terms of B, right? So, okay, I will show you both ways. I will show you quadratic formula. Remember, quadratic formula is given by, let me write over here, minus B plus minus square root B squared minus 4AC over 2A. So my B is 10, right? Then you take the 10, you square it. You can, in fact, you can just write 100. You can just write 100 minus 4AC over 2A. My A is 1. So the next step is, let's simplify this. 10 squared is 100. 100 plus 4P, you divide by 2. Okay. Now, 100 and 4P, actually, we can take out a common factor. Your common factor is 4. We can take out 4. That would be 100 divided by 4 gives us 25 plus B, this is B, divide by 2. Square root of 4 is 2. So we can write this as plus minus 2 square root 25 plus B over 2. So when you divide them, this will be negative 5 plus square root plus minus square root 25 plus B. Okay, from here, remember this is quadratic inequality. So for quadratic inequality, we have to sketch the graph. The roots of this inequality, as you can see, one is negative 5 minus square root 25 plus B. Another is positive 5, negative 5 plus positive 25 plus B. Now, since this region is less equals 0, so we have to shade the region below. Yeah, this is P. The region below is here, right? Remember, below this, if you want, you can treat this whole thing as your Y. This whole expression here as your Y, right? If it's less than 0, your Y must be below here. You shade the region above, right? And your answer is between these two values. So you can see your range of values is between -5 minus square root 25 plus b, and this is your x value. This is your, sorry, this is your x value. I should write this is x. And this will be -5 plus square root 25 plus b. Well, most of the people will just stop here, right? But we know that if you take any value of p, p is a positive value. You take -5 minus this, it's going to be negative. Now, your length of x can't possibly be negative since x is greater equal 0. Now, take note that there's equal sign here. Yeah, so I need to add an equal sign here. But because x is greater equal 0, we ignore the negative side. We just take x between 0 and -5 plus square root 25 plus b. Okay, so there you go. That's the answer. Now, well, by the way, sorry, we cannot add 0. X can't be 0. X is more than 0. So this is the first part here is non-inclusive. This is inclusive. Okay, I'd like to offer you another method of solving because I personally like to use completing the square more than quadratic formula. Because for some question, completing the square is easier. Like in this case, when you take half of 10, it is just 5. You square it. And 5 square is 25. You minus b. Yeah, you really learn how to complete the square, right? But take this number here, the coefficient of x, then half of it is 25. Half of it is 5. 5 square is 25. But you always put the negative outside. Yeah, the reason being because if you expand this bracket, you always have an additional 25 here. So we have to subtract it off. All right. Now, the next thing is I'm going to bring the 25 and b to the right-hand side. So when I bring this to the right-hand side, it becomes 25 plus b. And every time you square root, there is a plus minus involved, right? So there is a square root with a negative 25 plus b and a square root with a positive 25 plus b. Now, the one with negative, when you square root, you need to change the symbol. The one with positive, we maintain the symbol. Now we can actually combine them and write x between -5. Okay, let me bring this over first. Yeah, one more step. Bring this over first. -5 minus square root 25 plus b. X less equals -5 plus square root 25 plus b. Okay. But we need to combine them. So when you combine them, you will get the same answer as what I've written in the first method, right? This is square root 25 plus b. This will be -5 plus square root 25 plus b. Now again, because x is greater equal 0, should I say greater than 0? So your final answer x is between 0 and -5 plus square root 25 plus b. Yeah, I know the number is a bit annoying because you have to leave answer in terms of unknown, and then you have to draw a graph or use this method here, solving using inequality. Yeah, that's why this question is a bit more challenging for most students, right? Okay, let's move on to part B, also quadratic function. The first thing is you have a diagram that shows the graph of y equals x minus 3 squared. When the graph is reflected in the line y equals 9, this function is obtained. Y equals negative x minus m squared plus q is obtained, where m and q are constant. So determine the type of roots. Okay, so here's the thing. Where is y equals 9? Now, we don't know. Yeah, it could be here, right? Around here. So let me draw a horizontal line. Y equals 9. So when you reflect in the line y equals 9, so what happened is this graph here is now inverted, upside down. Okay, And this graph will have an equation of negative x minus m squared plus q. Okay, so the question is, what is the type of root for this equation? Actually, it's not difficult at all. As you can see, when you reflect up, what happens is when you extend all the way down, right? The equation for this equals 0. Look at this equation here. At x-axis, your y is 0, right? The number of solution to this equation, negative, let me just use this, to this equation, negative x plus minus m squared plus q equals 0, is the number of intersection. So from the graph, you can see, yeah, there are two intersections, right? So two intersections here. Okay, so your number of solution is two solution. Okay, let me write two solution. And because you have two solution, how many roots? What type of roots do you have? We say real and distinct roots. Now remember, if it crosses at touches at one point, let's say you have a graph like this, touches one point, one real root, crosses at 2 point, two real root. We say this real and equal root. This is real and distinct root. And if it doesn't intersect, it has no real root. Actually, since this is a 1 mark question, you can just write real and distinct root. Right? You don't have to explain all these things, but just want you to know, once you reflect, you can see the graph here, the red color graph here, it intersects 2 points. Therefore, you will have two real root, or we say real and distinct roots. Okay, moving on to question number 5. So this is a simpler question. Form 4, chapter 1, function. Okay, so the first thing is I need to find the domain. Domain represent your x value. So these are what we call it. This is what we call a discrete function. It has a single value for all of them. So your domain will be your x value. We start from 1. You have 2. You can see domains your x value 1, 2. Next one will be 4 and 5 and 7, right? 1, 2, 4, 5, 7. That's it. Okay, how about range? Range is your y value. My y value will be 2, 3, 5, 6, 8. So we write 2, 3, 5, 6, 8. All right. Moving on to second part. Yeah, very simple. Okay, so here we have a function that maps x onto y and y onto z. You're given function f here and function g. So gy is given, and this is your fx. Yeah, fx is given. So your fx in this case is 3x minus 7. So what we want to do is we want to find the function that maps z to x, the other way around. Now, first of all, we know this function is called a composite function gfx. Gfx simply means putting fx inside gx. Fx happens first, followed by gx. Now we know our function gfx is 3x minus 7. I put inside my gx. My gx will be this, right? 8 over 4 minus bracket x, 3x minus 7. Okay, so the next thing is we can simplify further and write 8 over 4 minus 3x plus 7. That will give us 8 over 11 minus 3x. But this is the function that maps x onto z. But now what we want to do, you want to go backwards. We want to go from z back to x. That means you're finding the inverse of this gfx. So for me, when I inverse a function, I always let this inverse becomes 1. Yeah, just to take note, your textbook uses gfx equals to 1. Gfx equals to 1. They do it this way. Yeah? Later on, if you want, can watch my other video that will explain that why this method is easier than this, right? However, if you wish to use gfx equals 1, go ahead. Yeah, you will get the same answer. So I let this be y and I interchange. Let it be x. Yeah, you will know, and I hope you really know how to interchange this. So when you have, let's say, for example, this function is the whole thing is gf inverse x. Yeah, that means we start from x, we go backwards, we get 1. Now, when you go forward, you're starting from y, you get x. That means y is your object, x is your image, the other way around. Now we know your gfx. Gfx is 8 over 11 minus 3x. Your gfy will be 8 over 11 minus 3y. And I'm solving for y. Yeah, I'm finding y because y is my gf inverse. So let's cross over. So 8 is now 11x minus 3xy. I'm finding 4x. So I bring this over, I'll get 3xy equals to 11x minus 8. My y is therefore 11x minus 8 over 3x. What we need to do is just to rewrite this, right? We rewrite g, your y is gf inverse x. This will be 11x minus 8 over 3x. And normally we have to write your x is not equals to 0. Yeah, the function becomes undefined when your denominator is 0, right? Your denominator here has x here, so we can't have x equals to 0. Okay, now let's say if you insist, I can show you gf x equals to y here. We interchange, gf inverse y is now x. So I need to find x. So if you're using this method, you take 8 over 11 minus 3x here, over here. We let it be, in this case, we let it be y. We're finding x instead of y. So you multiply over, you notice the same thing, but now instead of finding a y, we're finding x. So you bring over 3xy is now 11 minus 8. All right. Your x is now 11y minus 8 over 3y. We just have to interchange because your g inverse y is now x. So if you want, you can rewrite gf inverse y is now, in terms of y, just change it to x. Yeah, gf inverse x is therefore 11x minus 8 over 3x. We just write x can't be 0. So you notice the result, the end result is the same. So this is the function that maps z onto x. Okay, let's move on to part C. So this is sketching graph. Yeah, you have to sketch the graph of h inverse. So we have the graph of hx, and on the same diagram given, sketch the graph of h inverse, state the corresponding coordinates. Now, you know by now, I hope you know by now, the relationship between function and inverse is that it is a reflection in the line y equals to x. So number one, what we can do is we can draw this line here, the line y equals to x. The dotted line we do, we can use a ruler. So this is y equals x. So when you reflect this coordinate of 2, 0, it will be reflected over here. The coordinate becomes 0, 2, or you can just map as 2. As this curve is going this direction, when you reflect up, it will go in this direction. Okay, my graph doesn't look very nice. Let me adjust it. Okay, I hope it looks better to you. Okay, once again, yeah. Okay, so this is your y equals to h inverse x. That's it. That's all we need to do. Just draw a reflection. They say state the corresponding coordinates. So to state the coordinates, so we can say the coordinates in this case is just 0, 2. Yeah, so you reflect over the corresponding coordinate of 2, 0 here, it becomes 0, 2. Okay, moving on to question number 6. This is quite a simple question on vector, right? Form 4, chapter 8. You're given vector A is 5 minus 3, vector B is 2 minus 12. Number 1, find B, 2A minus B. Okay, 2A minus B in this case means we put the A inside 5 minus 3. This is in the form of a column vector. So just multiply inside 1 by 1, 10 minus 6. This is minus, the minus 2, I don't want to multiply the negative inside first. I'll just leave it out. This is minus 12. So when you add them together, right, you should get 10 minus 2, which gives us 8, minus 6 plus 12, which gives us 6. So you get 86. Okay, now next, find the unit vector. Okay, again, I want to show you two different methods. Yeah, most people, what would they do is for unit vector, right? Normally we don't write like this, like, we put everything under the roof. No, we don't put that way. A unit vector is defined as a vector that moves in any direction, a certain direction, but it has a magnitude 1. So to get a magnitude 1, right, so we need to take this vector, we divide by its own magnitude. For example, the magnitude can be 5. When you divide by 5, you get 1 unit of it, right? Just like buying vegetable, right? Price of 5 kg is 10 ringgit. Price of 1 kg divided by 5, you get the 10 divided by 5, get 2 ringgit per kg, right? So you're finding per unit of a particular vector. So what most people will do is that they'll take this vector, they divide by its magnitude. Yeah, this vector over here. Well, we can just represent this with another symbol like u, unit vector. All right, you can say let u be 2a minus b. The magnitude u will be 8 square plus 6 square square root, which gives us 10. Your unit vector of u is just 1 over 10, 8, 6. Now, instead of dividing like this, normally we don't write like this. Okay? For column vector, we always write times 1 over 10 instead of dividing by 10. But you can also write as 8i plus 6j divided by 10 if you like. Right? It is the same. But notice we can simplify this because 8 and 6, they're divisible by 2. So we divide both by 2. So you divide by 2, or should I say I take out factorize the 2. This is 2 over 10. This is 4, 3. Answer is 1 over 5, 4, 3. But for me personally, this is a bit slow because I have to find the magnitude and I have to simplify further. So now I'd like to go through another method, which is easier because we know that when two vectors are parallel, they must have the same unit vector. I can have a vector going this direction, another vector going this direction. They're parallel. The unit vector of the first vector is here, right? The unit vector of the second vector is also here because they are moving in the same direction and they both have 1 unit. So what I'll do is, from your first part here, the 2a minus b, I'll take out the 2, I'm left with 4, 3. I'll just factorize 2 from here because 8, 6 is actually parallel to 4, 3. Yeah. Let me say this again. When two vectors are parallel, the first vector is a multiple of second vector. So this vector and this vector, they're actually parallel. Just one is longer than the other. Right. So let me know the magnitude of 4 and 3. You know, it's 3 square, 4 square. You should get 5. Yeah. Right. So if you want to cut short your working, you can just say unit vector is 1 over square root 4 square plus 3 square. This is 4, 3. And my answer is 1 over 5, 4, 3. There you go. A lot shorter. So we don't have to like divide and simplify further like what I did here because you still can simplify to the lowest term. All right. Okay, let's move on to part B. All right. The part B is coordinate geometry. Yeah. Actually, normally they don't, for a particular question, it will be from the same chapter. Part A and part B usually be from the same chapter, but this one is vector. Second part is coordinate geometry. Okay, so here we have C is the midpoint of AB, and E divides the line segment CD such that HED is KCD. Okay, I think first thing we find the midpoint. Yeah, C is the midpoint, so I'll write C as the midpoint of AB. A is 2, B is 6, so 2 plus 6 divided by 2, and 0 plus 6 divided by 2. You can see here, 2 plus 6 divided by 2, 0 plus 6 divided by 2. So your midpoint is just 4, 3. Okay, the second step is this. You're given the ratio. Actually, there is, I would say, this question can be better if they ask you to find H and K first, right? Because if they don't ask you to find H and K, right, we know this is 4, 3. And we're supposed to find R. So we don't need to find the ratio because we know if 3 points lie on the same line, they must have the same gradient, right? So we can just ignore this totally. We can just use gradient method. Okay, let me show you the gradient method. right? Then I show you the changes, okay? Now, if you use gradient, right? Gradient of DE equals to gradient of DC, or maybe I should say EC. EC is easy, right? Is no unknown. Your DE will be, let me use y2 minus y1, negative 4 minus 0, r minus minus 2. And EC, it is, let's say, I take, now it doesn't matter whether I use 0 minus 3 or 3 minus 0, but it must be the same. For example, 3 minus 0, I must take 4 minus minus 2. I cannot take 2 minus 2 minus 2 minus 4, the other way around. And you notice the gradient should be positive, the gradient is going up. So this will be negative 4 over r plus 2 equals to 3 over 6. 3 over 6 is 1 over 2. So when you cross multiply, when you cross multiply, your r plus 2 is now negative 8. Your r is negative 10. So it's very short for 4 marks, right? Yeah. Okay. R equals negative 10. Maybe I should do a bit higher here. You can't see. R equals negative 10. Let me write this over here so that you can see the whole page. Okay. So this will be r plus 2 equals negative 8. R is negative 10. Okay. But what I would say is that the question probably should say find h, k, and r, so that it's fully justify the 4 marks given. Okay. Now, the interesting part about this is that you're given HED equals to KCD. So that means ED over CD. Let me write over here. This is method 2. Let's say if they ask you to find HK and R. So we can say ED over CD is H over K. Now be careful. A lot of people tend to put H and K inside straight away. Your ED is H, but K is the whole thing, is CD. This whole thing is your K. So therefore, this ratio should be K minus H. Yeah, be careful about that, right? Okay, now let's say, assuming they ask you to find HK, right? So we use the ratio, the divisor of line segment. Yeah, we call it the ratio theorem. Okay, the formula works like this. We take a point in between equals to what? N x1, M x2, M plus N, N y1, M y2, M plus N. So the main thing to understand is that the N and the coordinate must be, the ratio and the coordinate must be opposite. You cannot take M multiplied with coordinate point C. You must multiply with the opposite coordinate, right? So here, let me start off with the Y coordinate. I don't do X coordinate simply because I do not know what is my R, right? Okay, so let's start with my Y coordinate, okay? You can do X first, then you leave it out, then you do Y, okay? But I just do Y first, okay? Y coordinate is 0. The point in between here is 0. My N is K minus H, right? I multiply with the opposite X coordinate, negative 4. Then I take my H, I multiply with opposite coordinate, Y coordinate, which is 3. Then I divide by my total ratio, which is, now your total ratio don't have to count. Why? Because you take these two plus together, the total length is K, isn't it? Isn't it K? You can take H plus K minus H, you still get K, right? So next, we multiply over, this becomes 0. This would be minus 4K plus 4H plus 3H, right? Bring this over, what would you get? You will get 7H equals 4K. H divided by K is 4 divided by 7. Okay? In this case, your H will be, if you want, you can rewrite like this. Your H is 4, the ratio of H and K to the lowest term. In this case, H is 4, K is 7, right? So in this case, you can see 4 ED is the same as 7 CD. Okay, so if this is 4 to 7, all right, if this is 4 to 7, let me just highlight for you. This one is now 4. 7 minus 4, the difference is 3. So now let's do your x coordinate, right? So you notice it's actually easier to do y first because we can find the ratio, and then we find our r by working on our x coordinate. So my x coordinate in this case is 3 multiplied by r, right? Okay, maybe I write the coordinate in between. First, the coordinate in between your x coordinate is -2 here. We take 3 multiplied by r plus 4 multiplied by another 4. Total ratio is now 7, right? We know 7 here. Times over -14 is 3r plus 16. All right, the 16 I bring over, 3r is -14 minus 16 is -30. -30 divided by 3, -10. All right, so let's move on to the next question. This question 7 is Form 5, Chapter 6, Trigonometric function. Okay, so here we have a trigonometric equation in terms of cos. In fact, it's a quadratic. You can see it's cos square here. So number one, you need to calculate what is cos pi over 3. So that we can sub in a cos pi over 3, we can actually find the value. You use your calculator here. Now just change your calculator to radian mode, shift mode. Number 4 for radian. Press cos pi over 3. You should get 1 over 2. Now, I know those who don't have this calculator, you can still do the 570 MS, the gray calculator. It can also do this. But I think you will get 0.5. Yeah, the answer will be 0.5. But change your calculator to radian mode, right, so that you can find this value directly. So I'm going to put a half here, 0.5 or half. Let's bring the cos over to the left. So this is 15 cos square x minus cos x minus 2. The result is 0. So to factorize this, first we take the factor of 15 times 2. 15 times 2 is 30. The factor of 30 will be what? 30, I want to get 1. So 30 and 1, 15 and 2, 10 and 3, 6 and 5. Right? 6 and 5 will give us 1. So I need to break this up to 5 and 3 because 15 is 5 times 3. Now one of them will give us 6. This will give us 6. Another will give us 5, right? So I'll need to put a 2 here and a 1 here. And this is a minus and a plus. So cos x is 2 over 5. And cos x is -1 over 3. Okay, now with that, we have to use your calculator to find the reference angle. Shift cos 2 over 5. Now remember, this answer is in degree, so be careful. You got to change your calculator back to degree mode, right? Otherwise, your answer will be in radian. So this is 66.42. Your reference angle is 66.42. Yeah, angle always give 2 decimal point. Answer correct to 2 decimal point. Second one, shift cos 1 over 3. Remember, drop the negative. The negative tells which quadrant the angle lies in. In this case, I got 70.53. Yeah, reference angle is 70.53. Okay, so what I need to do next is to work out the general angle. Remember, reference angle is the angle that we take from where we stop towards the x-axis. When your cos is positive, ASDC, we have to assign them in quadrant 1 and quadrant 4. So for the first part, your first answer is 66.42. But the second answer, you need to go all the way from here to here. Yeah, quadrant number 4, right? This is 66.42, 66.42. We should take 360 minus, right? 360 minus 66.42. So you can work it out. Answer is 66.42 for the first one. Second one is 293.58. Again, you can't work out mentally. Just use your calculator, okay? Now, the second one, cos is negative. This is for positive. Cos is positive quadrant 1 and 4. Cos is negative in quadrant 2 and 3. So my first answer is 70.53 over here. Second answer, 70.53 in quadrant 3. So we write quadrant 2. Remember, we are finding the general angle now. The general angle is measured from positive x-axis. So first one I need to do 180 minus. Second one I need to do 180 plus. So let's work it out. 180 minus 70.53 and 180 plus 70.53. So the first answer is 109.47. Second answer is 250.53. So all in all, you should have 4 answers. 1, 2, 3, 4. 2 for the first set of answer and 2 for the second set of answer. All right. Okay, moving on to question number 8. So this is a question involving integration, not differentiation, although there's differentiation involved. This is what we call differentiation as a reverse process of integration. So we know that if I differentiate a function, let's say fx, I will get gx, right? So when you integrate gx, you will get back fx. But normally for integration, in definite integral, we need to put a plus c. So you don't have to do integration. You don't have to integrate anything. We just have to use the result. That is, when I integrate this whole expression over here, let me just copy 2x plus 1 square and 4x minus 19 divide by x minus 3 square dx. Your outcome will be the same as this, which is 2x plus 1 power 3 over x minus 3 plus c. Yeah, add in a plus c. Okay, next I want to use this result to find this. Now, one thing to take note is that there is an extra 8 here. This is 8 and this is 38. But what I have over here is 4 and 19. So we know 4 times 2 gives us 8. 19 times 2 gives us 38. At the same time, take note I have a 3 here, but I don't have a 3 over here. So that means that what I need to do to go from this line to this is I need to multiply 2 over 3. So when I multiply 2 over 3 on the left, okay, let me just write 2 over 3 first one by one. 2x plus 1 square, 4x minus 19. I divide by 3x minus 3 square dx. This will be 2 over 3 as well. I need to multiply both sides, right? So this will be my 2x plus 1 power 3 over x minus 3 plus c. Now, your c is a constant, arbitrary constant. So we don't have to multiply 2 over 3 because we don't know exactly what is the c value. You times it 2 over 3 is still another c, right? The c for the first one can be different from the second c over here. Now, the next thing is I would like to multiply the 2 inside here so I can get the same thing as this, 8x minus 38. So let's write 2x plus 1 square, 8x minus 38, divide by 3x minus 3 square dx. All right. At the same time, I'm going to add in the limit because my limit is from 4 to 5. Okay, when you add in the limit, is what we call a definite integral. So we have to put a square bracket here. Now, whether you keep the 2 over 3 inside the square bracket or outside, it doesn't really matter. It doesn't affect your definite integral. So I'm just going to leave it outside. And when you have a definite integral, we don't have to write this c anymore. Yeah, this c over here, no need to write anymore. No need to write. So we can just substitute the limit. Okay, to sub in the limit, we take 5 and put inside here. 2 times 5 plus 1 power 3. Then you have 5 minus 3. And I subtract first, then I sub in 4. 2 times 4 plus 1 power 3 and 4 minus 3. So what we have here, we can cancel and simplify this. This is 11 cubed, 2 over 3, 11 cubed over 2. And this will be 9 cubed over 1. 9 cubed over 1, I just write 9 cubed. Now, in fact, you can actually calculate this straight away using calculator. You don't have to write so many steps, right? I just want to show you here. This is 11 cubed over 2. Then you minus 9 cubed. My answer is negative 127 over 3. Now, it's okay to leave your answer as mixed number here, like this, improper fraction, sorry, or even a mixed number, right? Negative 42, 1/3. Okay, moving on to question number 9. All right, this is also integration. Number 8 also integration. Number 9 also integration. So here we are supposed to find the value of m, given that definite integral of this equals to 65 over 81. Okay, so number one, when you integrate involving composite function, I hope you know this. Integration of this, we need to increase, copy your k, copy your bracket, increase the power by 1, divide by the increased power, and differentiate whatever inside the bracket. So in this case, let's just copy 2 minus 1/4x, increase the power by 1, -5 plus 1 is -4, divide by -4, differentiate inside is -1/4. And this result is now equals to, but first of all, let's put a limit, 4 to m, equals to 65 over 81. Now, notice we can cancel 4 and negative here. In fact, the negative, we can cancel out everything. So you're left with 2 minus 1/4x to the power of -4. This is now 65 over 81. All right. What is power negative? Actually, power negative means 1/n, right? 1/n, a power n. So we can actually bring this down, right? And this is 65 over 81. By the way, I forgot my limit. I need to put my limit here. M to 4. Yeah. This one, I better write the limit from m to 4. Okay, very slowly. I do this first. All right. So let us sub inside. 4 inside. So this will be 1/2 minus 1/4 times 4. All right. The whole thing power 4. Then 1/2 minus 1/4 m. The whole thing power 4. 65 over 81. Now, the good news is 1/4 times 4 is 1. 2 minus 1 is 1. 1 power 4 is also 1. 1/1 is still 1. So now you're left with 1 minus 1 over 2 minus 1/4 m power 4 equals 65 over 81. Now, the next thing is I need to bring this over and minus 1 minus 65 over 81 is now 16 over 81. You can bring it over. Okay, again, I'm bringing this over. This is 1/2 minus 1/4 m power 4. Okay, if you're not sure, just use a calculator. 1 minus 16 over 81. 65 over 81. You will get 16. Okay, I just want to show you how I got this. Okay, now then we can invert both sides, or you can cross multiply. It's the same thing. This will give us 81 over 16. The next thing is we have to root it. Now, I hope you know that if I give you x squared equals to 4, when you square root 4, you have to put a plus minus, right? So let's say this is this is 4, so square root is plus minus 4. Now, if I say x power 4 is 16, now 16 is actually 2 power 4. So we can't just say it's 2 because -2 power 4 is also 16. 2 power 4 is also 16. For even power, like power 2, power 4, there's always two answers. There's always a plus minus because a -2 power 4 is also positive. Yeah, positive 2 power 4 is also positive 16. They are both positive 16 the moment you power it. Okay, so now the next thing is because of that, right? You need to work this out separately. There are two answers. All right, maybe I write it over here is better because it looks like I got more space over here. 2 minus 1/4 m equals to -3 over 2. And let's work out the positive one as well. Positive 3 over 2. Now, if you're not sure, you can use a calculator. You can just take shift power here because it's power 1 over 4. Yeah, we put in your 81 over 16, you will get 3 over 2. Yeah, but please add a negative and a positive. Okay, now I'd like to bring this over, right? 2 plus 3 over 2 is 7 over 2. So the negative 1 over 4 I bring to the right, it becomes positive 1 over 4. Let me just write positive 1 over 4 equals 7 over 2. Multiply over m is cancel 2 and 4. Left with 2, 2 times 4, 14. Yeah, 7 times 2, sorry, 14. Yeah, cancel that. So this one you bring over 1 over 4m is now 2 minus 3 over 2, which is now 1 over 2 multiply over m is 2. However, you can see that the question says m is less than 4, right? If m is less than 4, we don't take 14, right? Okay, maybe I just write here, since m is less than 4, m has to be 2. Okay, there's one way to double check your answer using a calculator. You can actually use this calculator over here, use the integration sign. All right, I put open bracket 2 minus 1 over 4 alpha x close bracket power negative 5. Lower limit is, in this case, m is 2. Upper limit is 4. Let's just count. I should get 65 over 81. So that I know my answer is correct. Yeah, answer M is 2. Okay, moving on to part B. It's a very interesting question. All right. Okay, so here we have a straight line y equals 10. It's a tangent to a curve y equals gx. It's given that g double prime equals to negative 4. Find equation of the curve. Find the equation curve when g prime 1 equals to negative 8. Okay, actually, they should say given that, not when. The curve has a fixed equation. And remember that when you are given g, you differentiate first time, you get g prime x. You differentiate second time, you will get g double prime x. So to find gx from g double prime, the g double prime is given, you need to integrate twice. The first time you integrate your g double prime x, you get your g prime x. The second time you integrate, then you get x. Okay, so let's start off by finding g single prime x by integrating your g double prime. So your g double prime is negative 4. When you integrate, you get negative 4x plus c. Now, because you have two parts of integration, normally we just write two different c. Yeah, the first c, I'll call it c1. The second c, you can call it c2. Okay, to find the value of c, we can use this information. G single prime 1 is negative 8. Yeah, so maybe should I say sub? You can write in coordinate form. In coordinate form, okay, I'll just write like this. G double single prime 1 equals to 8. Your G single prime means your gradient. That means at the point where x equals to 1, the gradient, maybe I draw the other way around because the gradient is negative. At the point where your x equals to 1, the gradient is negative 8. Gradient tangent is negative. Is negative 8. So I need to put a negative here. Sorry, there's a negative here. So let's sub inside negative 8 equals negative 4 times 1 plus c1. Bring the negative all over. Your c1 is now negative 4. So my g prime x is now negative 4x minus 4. Now, I need to integrate second time to find gx. But to find the second value of c, I need a coordinate. Now, notice you're not given any coordinate, but they say y equals to 10 is the tangent to the curve. Yeah. So when a line is a tangent to a curve, okay, so a line is a tangent to the curve. So let's say the curve looks like this. That means when x equals to this value, which I don't know, y equals to 10 touches the curve at one point. And y equals to 10, as we know, is a horizontal line. If a horizontal line touches the curve at one point, that means this coordinate is your minimum point. Now, it can be maximum though. It can be maximum. This is also a tangent, right? Y equals to 10. Okay, but it doesn't matter. The most important thing is that at these 2 points, whether it's minimum or maximum, your dy dx is 0. So we're going to let your dy dx here be 0. From here, from this equation over here, your dy dx is your g prime x. You let it be 0. Let's solve for your x coordinate, because I need the x coordinate to be able to find the second c for your gx. So let's bring over negative 4x is now 4, x is now negative 1. So we know that at this point your y is 10. So your coordinate of your turning point is minus 1, 10. What I need to do is to find the second value of c. So we have to integrate your g prime x here to get your gx. So when I integrate that, remember, you have to copy, increase the power by 1, divide by the increased power. If it's a constant, we add the x, then we put a second c. Okay. Now here, you don't have to write so long. You can straight away write minus 4. Don't need to write minus 4x. Minus 4 divided by 2. Straight away write minus 2x. Okay. Don't need to write minus 4x over 2. So we have to simplify further, right? Okay, to find the value of C2, we sub in minus 1 and 10. That means your y or your gx is now 10. Your x is negative 1. This is negative 1 plus C2. This is now minus 2 plus 4, which gives us 2. All right, I bring it over. My C2 is now 8. Therefore, my equation, I'm finding equation of curve, which is my gx. I let it be minus 2x squared minus 4x plus your C2. Your C2 here is now 8. Okay, let's move on to number 10. Okay, this is from 5 chapter 4 permutation combination. Part E. A group of students consists of 4 boys and 4 girls have attended the event. In the event, they are seated in a round table with 8 chairs. Okay, find the number of different arrangements for all of them. Okay, so we got 8 people. Yeah. Now, before I explain the round table, let's do a simple arrangement in a row. We know 1, 2, 3, 4, 5, 6, 7, 8. All right. So if you have 8 people, the number of ways to arrange is what? 8, 7, 6, 5, 4, 3, 2, 1. So number of ways is just 8 factorial. However, if you tie all the people together and then like a chain, if you like, and we join the first and the last together such that they go in a shape like this, a circular shape like this. So what happened is there are 8 different positions. I can put the first person. So let's say the first person is A for Ahmad. I can put Ahmad here, right? Ahmad will have Ben on his right, let's say. And this is C, D, E, F, G, H. H is, let's say, Ho. Ho will be seated next to Ahmad here. But I can actually rotate them and put them in 8 different positions. For example, I can put Ahmad on here, second position. I can put here, third, fourth, fifth, sixth, seventh, eighth. So when you move Ahmad in 8 different positions, he will still have Ben and Ho on his left and right. So it's actually the same arrangement in a round table. So for round table arrangement, you always have to divide by 8, right? Or some people say 8 minus 1 factorial. Yeah, which is the same, 7 factorial. And if you use your calculator, you should get 5040. Let me show you on the calculator. So 7 factorial over here, 5040. Now you can use 8 factorial divided by 8. It's the same thing. You still get 5040. All right, so that is the first part. Second part, all of them have been asked to perform that line, how many ways of different arrangement, so that all the girls will stand in the middle of the line. So you have 4 girls, 4 boys. If all the girls stand in the middle, you must have boy, boy, girl, 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 boy, boy. That means you put boys, 2 boys at the end on each side, and 4 girls in the middle. Okay, so we have 4 particular girls. Okay, so let me put the girls first. 4, 3, 2, 1. And you have 4 particular boy. You can start from left, start from right, doesn't matter. So let me start the boy from left. 4, 3, 2, 1. So actually it is the same as having 4 factorial for the girls and 4 factorial for the guys, multiply together. Now let's use our calculator. 4 factorial, you times another 4 factorial, wait, we can actually square it, right? You get 576, yeah, 576. Okay. All right, first part is permutation. Second part, this is combination. So Biden Wakil Pelajar, which consists of 3 girls and 2 boys, okay, they are selected as representative for the leadership camp. 3 representatives will be selected as presenter. During the camp, how many different ways to select? At least 1 girl as a presenter. Okay, so we have 3 girls and 2 boys. You're required to find at least 1 girl. At least 1 girl means you can have 1 girl, 2 girls, or 3 girls, right? So if I choose 1 girl, then I must choose 2 boys. If I choose 2 girls, I must choose 1 boy. If I choose 3 girls, I don't have to choose any boys. So there are 3 cases here. You can call this case number 1, number 2, and number 3. So let's just put them together. Remember, when you choose the boy for the first case, you have to choose the boy and the girl at the same time, simultaneously. So in this case, we say 3 girls, I choose 1. At the same time, this is n. N means that occur simultaneously, you have to multiply. 2 boys, I choose both of them. Then you put a plus. Plus is or, case by case. Can be case 1 or case 2 or case 3. We add up all 3 cases. So 3 girls, I choose 2. 2 boys, I choose 1. This one happens simultaneously, I times. Or 3 girls, I choose 3. 2 boys, I choose none. Now use your calculator. We can actually do one shot. We can do one shot. Don't do one by one. 3C1 is actually 3. But if you're not sure, you can just type in the calculator. 2 choose 2 is actually 1. Actually, you don't have to write. But if you want, I can type in for you like this. 3 choose 2 will be actually 3 as well, right? 2 choose 1 will be this is 3, this is 2, and then 3 choose 3 is 1. Yeah, you don't have to type. If the one 2 choose none is actually 1. So you can add up. Your answer is 10. Okay, moving on to question number 11. This is Form 5 chapter 5 probability distribution. So first we want to find the value of n. You're given that this is a binomial. When you write like this, means it's a binomial distribution. N is not given. Probability of success is 0.4. So first part, we are finding the value of n. Okay, so to find the value of n, I think we have to use this value here. This probability x equals to 0, which is 27 over 125. Now, remember the formula is Px equals to R, NCR, P power R, Q power n minus R. Now, your n is now an unknown, so we put NC0. Your P is now 0.4, right? 0.4 over here, you can see from here. Power 0, your Q is 0.6, power n. This is 27 over 125. Now we know NC0 is 1. 0.4 power 0 is also 1. So now you're left with 0.6. Okay, for those who are not sure, NC0, you can just put even 100, C0, you get 1. Okay, anything power 0 is also 1. So the 0.6, we can change to 3 over 5. And this 3 over 5 power n is now 27 over 125. Now we know 27 is 3 power 3. 125 is 5 power 3. But if you're not sure, you can just use your calculator. Don't have to use logarithm in this case, which is power 3 here. You can see. By comparison, we can say that your n is 3. Okay. Now then they say, hence, complete the diagram. Well, to complete the diagram, I need to find out 2 more values, x equals to 2 and x equals to 3. We need to find these 2 probability. So the probability of x equals to 2 is now n is 3, choose 2, p is 0.4, power 2, q is 0.6, power 1. Now we can multiply a calculator as usual, but I like to show you this calculator because this calculator can do even faster. You press mode 7, you go to number 4, binomial PD 4, Now, you can choose to calculate individually or multiple value. Individually means we take variable 2. Your x is now 2. Your n is now 3. Your probability is 0.4. And then you count, you will get 0.288 or 36 over 125. Now, since everything is given in the form fraction, I'll take 36 over 125. Yeah, instead of multiplying the normal way. Now, for x equals to 3, we have to choose 3, choose 3, b power 3, q power 0. Now, basically, this is 0.4 power 3, right? But again, you're not sure, you can use a calculator. Now, you can do the same as this, or you can go back to 7, go down here to binomial, go back to 7, binomial PD4, you go to list, because list can give us multiple value. So let's say I want to find 2 and 3. I put 2 and 3 here, I press equals, my n is 3, my p is 0.4, then you press equals, there you go. It will give us the property just now for x equals to 2, and another value for x equals to 3, which is 8 over 125. So I'm going to write here 8 over 125. Now with that, I'm going to label, this one is 36, so a little bit higher. Okay, my line is not very straight, so let me just draw one more time. This will be 36 over 125. The other one is shorter, 8 around here. Put a cross, put a cross. This is 8 over 125. All right. Okay, moving on to question number 12. This is a linear law question from chapter 6, linear law. So you're given a straight line and you're supposed to find the value of unknown h and k. H and k is in this equation. So number one, let's find out gradient. My gradient will be what? Let's take y2 minus y1 over x2 minus x1. Your x2 is 4, x1 is 2. Okay, 17 minus 9 is 8, 8 divided 2 is 4, 4 divided 2 is 2. You're not sure, you can use a calculator, is 2. Now, next we need to find y-intercept. In linear law, the two most important things you need to find is your gradient and your y-intercept. So we have our gradient. To find a y-intercept, I'm going to use y equals to mx plus c. Now remember, we have to use capital Y, capital X, because this is your capital Y, the variable on your y-axis. This is your capital X, the variable on your x-axis. So to find c, I just sub in a point, any point. Let me take this first point, because it's easier. Smaller number, 2 and 9. That means my y is now 9 over 2, 2 and 9 over 2. My x is now 2 plus c, bring over 9 over 2 minus 4 is 1 over 2. So my y is now 2x plus 1 over 2. Okay, now actually I don't have to write this because what I want is my gradient and my y-intercept. To find the value of unknown h and k, I think it's easier to start from here, the non-linear function, convert it to a linear form. Now, what to do to convert, it depends on the variable on your y-axis. You can see we have to introduce log. Your y has a log in front. So I put a log 10 y equals to log 10. This is h power x over the square root of k. So number 2, I'm going to break it out. In the laws of logarithm, we know my divide, when you break it out, it becomes minus. Square root of k, I'll leave it as k to the power half. Now, also we know that if you have a power, you can transfer it down. So this is x log base 10 h minus half log base 10 k. Now that log base 10 h, I can put first, the x I can put at the back. So this is now my big y, my gradient m, my big X, and my C. Okay, my gradient in this case, as we know, is here, 2. My y-intercept is now half. So basically, I just compare my gradient, my log base 10 h with 2 over here. So your h is 10 power 2. What is 10 power 2? 100. Then you continue with your y-intercept. My y-intercept from the equation is negative half log 10k. From the graph, we got 1/2. So log 10k is now, we can cancel, -1, k is 10 power -1. I hope you know how to change from logarithm form to index form. So that is, if I have log a y equals to x, my y is a power x. Okay, so in this case, 10 power -1, I got 0.1. Now you can even use your calculator. Yeah, we call this anti-log, like shift log -1, there you go, 0.1 or 1/10. All right. Okay, let's move on to question number 13. So this is a differentiation question from 5, chapter 2. Okay, now diagram shows a rectangular cardboard, KLMN, with perimeter of 10 cm, used to form a closed cylinder with a maximum volume. So the side KNLN will form the height of the cylinder. So that means if you take this cylinder, you fold this, roll it up, if you like, right? Join the K and L together, you will get a cylinder like this, all right? With a height Q, and your circumference will be P. All right, so they say diagram 10.2 shows 2 circles that will be cut from the cardboard to make the cover and the base of the cylinder. So you are supposed to determine by calculation whether the side TUVW here is suitable to form the cover of the base of the cylinder. Okay, so number one, I think it's best we take the circumference here. We know this is going to be a circumference, which is 2 pi r, and this is your height of your cylinder. Now, we know that this is going to be your curved surface area, and your volume of cylinder is given by pi r square h. Okay, my radius, I don't know, but I do know my perimeter is 100. So that means that we can say 2 pi r. There are how many 2 pi r here? 2 of them, right? And this is your height and height. Yeah, 2 pi r times 2 plus 2h. The result must be 100. So let's just divide them, right? Divide everything by 2. 2 pi r plus h equals to 50. Let's make h as a subject. 50 minus 2 pi r. So sub inside your volume, pi r square h. 50 minus 2 pi r. So when you expand it, you get 100 pi r square minus 2 pi square. There's a pi times pi is pi square. And then r cubed. Okay, so I got my volume, V, in terms of r. Now, in order to have a maximum volume, we know dVdr must be 0. So we differentiate dVdr first, bring the 2 down. I get, okay, sorry, I made a mistake here. This is 50, yeah, sorry, 50. This will be 100 pi r minus 6 pi square r square, pi square r square. Okay, at the point when you have maximum minimum, dVdr 0, and I think we can factorize this directly. Take out 2, take out pi, take out r. So you have 50 minus 3 pi r. Okay, at the turning point, when this is 0, you have 2 possible values of r. Your r is either 0 or your 50 minus 3 pi r is 0. Now we know r can't be 0. Your radius can't be 0. Yeah. So your 3 pi r must be 50. Your r must be 50 over 3 pi. Okay. So now I need to know whether this cardboard here is suitable. Now we know this is your radius. Double your radius is your diameter. So we want to check whether your diameter is less or equal to 11. If it's less than 11, we can cut out circle and it's suitable to fit it in, right? If it's more than 11, then you can't. So your diameter here is 2 times of 50 over 3 pi. So we can use our calculator to verify. 2 times 50 is 100. Divide by 3 pi. Now we can normally we use calculate. They would tell you to use 3.142, but even if you use a calculator pi, actually in this case it doesn't make a difference. 10.61. So if your D is 10.61, you can see that this is less than 11, right? Less than 11, correct? So we can actually have enough space to cut it out and to fit it as a cylinder. So is it suitable? Answer is yes. All right. The Y diameter is less than 11 cm. Okay, let's move on to question number 14. So here we have the members of Art Club MRSM wants to draw a mural on the wall for the college computer lab. So the design of the mural is congruent blue square, and the blue square shape from the 20th to 25th will be painted with red color. So we're supposed to derive the formula for the sum of the first n term of the number of blue square. Okay, we can see from the first row, your number of blue square is 1. The second row, you have 3, right? This is 1, this is 3, this is 5. So that means your common difference will be 3 minus 1, which is 2. Now, let's use formula for Sn. Now we know Sn equals to, this is an arithmetic, it increases with a constant rate, n over 2, 2a, n minus 1d. So we're going to use this formula here. We have to leave our answer in terms of n. Your a is 1, n minus 1, my d is 2. Okay, so let's do n over 2. Simplify this first. Now, actually, we can multiply the half inside. You can multiply the half inside, as in this half here. I times half, cancel, cancel. That will be a lot easier. You don't have to expand this bracket. So keep the n here. You're now left with 1 plus n minus 1, which gives us n, right? So n times n, your answer Sn is n squared. So the number of blue square is just n squared. The sum of all the blue square up to the first n row is n squared. Okay, then they say the blue square at the 20th to 25th will be painted with a red color. So calculate number of blue square that will be painted with a red color. So we know we are finding the number of blue square on the 20th up to the number of blue square on the 25th row. Yeah, 20th to 25th row, right? So to find the total number, we just take S25 minus S19. Now, for those who are not sure, let me show you here. T1 plus T2 until T19. This is T20 until T25. Now, this sum is the sum of the first 25th terms. If I want 20th to 25th, I must get rid of the sum of the first 19. By taking S25 minus S19, I'll get T20 to T25. Now, your S25 already have this formula here, Sn. We'll just replace this with 25, and I square it. Your S19 is just 19, and I square it. Now, you can just use your calculator here. 25 square minus 19 square. I got 264. All right. Okay, next one. In the next question, we have part B. This is a geometric progression. Previous one is arithmetic progression. So here we have information about rainforest based on the report from an NGO. So report also stated that average annual rate of deforestation is 0.8%. This is the number of rainforests, 785 million rainforests remaining from the all over the world from January 2021. Okay, so what we want to do is to find the remaining area of rainforest in millions hectare, right? For the end year. starting from 2021. So 2021 is your first term, 785 million. So I think we can just drop the million because your answer, you want everything in million, right? So we already know it's the same unit. Now, remember, when you reduce by 0.8%, you start from 100%. You minus 0.8%. You divide by initially 100%. So we can use 100 minus 0.8. So this is going to be 0.992. You divide by 100. Your common ratio is 0.992. Remember, if your common ratio is more than 1, it's increasing. If your common ratio is less than 1, it's reducing. So in this case, it's reducing by 0.8%. So you want to find in terms of n, the number of rainforests, the area of rainforest in millions that's left. So we use the formula A R n minus 1. Remember, formula for geometric progression, Tn is AR n minus 1. So that's it. We have to leave it like this. Yeah, that is your first part. Yeah. Okay. Second part. Hence, find the minimum number of years where at most half of the area will still remain from 2021. So we want at most half of the area in 2021, which is 785 million. Now we know your Tn formula already, 785, 0.992 power n minus 1, less equals to half of 75. Now we don't have to multiply this because we can actually cancel them, right? Cancel this too. All right, now you're left with 0.995 n minus 1. You can write this as 0.5 if you like, leave it as half, also no problem. To solve this equation, I'm going to introduce log on both sides of the equation. Bring the power n minus 1 in front, okay, 0.992. And then what you need to do is to divide them, right? Now use your calculator. Log 0.5 divide log 0.992, you should get 86.30. So n minus 1, 86.30. Now here's the thing you need to understand. Log of any number between 0 and 1. Let's say your number is y. If you have any number between 0 and 1, right? When you take the logarithm value, it is going to be negative. So how does this affect your inequality? Well, if you have a negative number, when you switch over, for example, minus 2x less equals to minus 6, when you divide it, we need to change the symbol, right? So I have to change the symbol here from less equals to greater equals. As you add with 1, you get 87.3, right? Now, remember, n is what? N is the minimum number of years. When we say it's greater than 87.3, that means it can be 88, 89, and so on. So the minimum value of n, if you like, we call it minimum value of n, is now 88, right? Yeah, it can be 89, it can be 90, and so on, but we want minimum. Minimum is 88. Okay, let's move on to the last one. This is circular measure. So here we have an organizer who wants to organize a virtual running event. So we have a plate here for the virtual running event. Well, the cost is 45. The 3 circles and all the shaded regions are congruent. The radius of the circle is 3 cm and the perimeter of each shaded region is 2 pi. So you're supposed to calculate the area shaded region. Okay, so first of all, you can see they say they are congruent and they give us the area. So let me just draw one. They give us a perimeter, okay? Okay, this is a bit ugly. One more time. Okay, so let's just draw one of them here, right? This part here, can you see? And we know that perimeter consists of this arc and this arc. Okay, so I have 2 arcs. So length of arc is s equals r theta. So we have 2 of arc. This arc s is now 2 pi. Yeah, perimeter is 2 pi. So if you're given also that the radius is now 3 cm, right? Radius, each circle is 3 cm. So this 3 cm, I don't know what is the angle theta. So we need to find angle theta first. So let's divide them. You get pi. That means one arc has length of pi. So let's use S equals r theta. Your r is 3. Theta is unknown. You get pi. Theta is pi over 3 radian. So they say calculate the area, right? Okay, so pi over 3, by the way, is 60 degrees. So to find the area, let's find how many this area do we have here. See, you can see one of them is here. 2, 3, 4, 5, 6, 7. Now, and to calculate this area, I like to use the formula for area segment because it's a lot easier. A segment consists of this, a sector like this, minus a triangle. Now, I like to use a faster formula, half r squared theta minus area triangle. You can see that this is a equilateral. In this case, a triangle with two sides given. We can use half AB sine C. Your AB are the same, R and R times together, sine of the angle in between. We can actually factorize this and write theta minus sine theta. So I always use this formula because it's faster, a lot faster. Now, the problem is, one area of this, of the shaded region here, you will have two segments. So in this case, each one has two segments, and I have total 7 of this shaded region. So your total area will be 7 of this times 2 times of area of segment. Now remember, formula of area of segment I've written here is, use the second one, half r squared theta minus sine theta. Your r in this case is 3. You square it. Your theta is pi over 3 minus sine pi over 3. Now here's the thing. Because they will always ask you to use 3.142, so you need to sub in 3.142 inside here. Or you can put here 3.142 divided by 3. But for this part here, you can use sine 60 if your calculator is in degree mode. If your calculator is in radian mode, we use pi over 3. So I would not use 3.142 like some people would change to radian mode and use sine 3.142 over 3 because it's not a very accurate value, right? But in this case, yes, actually about the same, right? So you can use sine pi over 3 here. This is Surds 3 over 2, right? Now, or you can leave your answer, change your calculator to degree mode and use sine 60. Yeah, Surds 3 over 2. So now I'm going to do one shot. We can actually calculate. The half and 2 can cancel. Left with 7. You multiply by 9. 3 squared is 9. I multiply with 3.142 over 3. Then I minus sine 60. Close bracket. There you go. 11.42. Yeah. So your total area is 11.42. It's actually very, very short, right? Yeah. For 6 marks, right? Because I do everything one shot, right? Yeah. So that is part A. Part B, organizer Y intends to color the shaded region with golden color. The cost of each color is 1.2, 1 ringgit 20 cents per cm squared. So calculate the percentage of incremental cost that will be borne by the organizer. Okay, so we'll obviously percentage of change in cost. We already know the original cost, right? Original cost is 45 ringgit, right? So we need to find how much more you have to pay in percentage, right? So the additional area that you have to color with golden color is this, yeah? Should I say additional cost? Additional cost will be 11.42 multiplied by 1 ringgit and 20 cents each. Okay, so 11.42 times 1 ringgit and 20 cents. Okay, this will be 13.70, right? RM 13.7. By the way, those who use, some people they take 3.142 divided by 3 first, they change decimal, they sub in. Also can, but sometimes if you do that, your answer may be a little bit off from the actual answer. That's why I like to sub in directly, 3.142 over 3 directly, and I like to use sine 60. Again, like I said earlier, you can use sine pi over 3. Okay, so this is your additional cost, but I want to find the percentage in change in your cost. Okay, up to you. Do you want to write in words? Okay, I just write percentage change in cost. There's an increment in your cost, 13 ringgit 70 cents per plate, and each plate costs 45 ringgit. You times 100, right? So we take this value, 1370, divide by 45 ringgit times 100. Guys, the additional increase in cost is 30.44%. 30.44%. All right. Okay, so that's all for the discussion for this MRSM paper 1. I hope you enjoyed this video and learned a lot in the process. Thank you for watching.